Hey, hi everyone, good morning. Okay, so last class we created the cluster and we executed, right? Cluster is ready. Oops, it can get on. Okay, so there is deployment running. Now, let's come back to the next concept, which is the namespaces. Now, what is this namespace? Okay, what is this namespace and why do you want to use this namespace? So basically, if you see, okay, there'll be a multiple teams in a company. Okay, they'll be having multiple teams like development team, QA team. They'll have Devops team. Okay, they'll have some data science, data engineering. Okay, so they have some support teams, etc. Things will be there, right? Multiple teams, and they'll have multiple environments as well. Multiple environments for multiple activities, right? So multiple environments like they have dev environment for developers, right? They have QA environment. Okay, then they have a test environment, then they'll have some production, some have stage, okay, some have like sandbox, okay, non-production kind of a thing. Then you have customer related environments, right? So multiple environments are there, multiple teams are going to use your cluster. Now imagine that if every team says I want a Kubernetes cluster of 3 nodes, that means they're saying that they want a cluster, okay, cluster where they have one master and 3 worker nodes. Okay, so if every team is asking this one, okay, if every team is asking this kind of a respective setup, so there'll be multiple teams and multiple environments. So then there is no use of, there's no meaning of cost optimization, right? It is similar. It is as you're using a VM based setup only, right? So I don't want to give everyone this one master 3 worker nodes. So maintaining that many clusters will be a headache, right? So how can you manage with a single cluster? How can you manage with a single cluster? Or 1 or 2 clusters is fine, but not multiple clusters. So what this namespace will do is, okay, this namespace is used for creating your subcluster. That means from what are the cluster you have, okay, subcluster from your physical cluster, okay, or you say in simple terms, dividing the physical, okay, cluster into your virtual cluster, okay, physical cluster into virtual clusters, okay. So namespace is used for creating a subcluster from physical cluster or dividing the physical cluster into your virtual cluster. That means I have only single cluster. I have one master or 2 worker nodes, or one master, 3 worker nodes. In that, I'll be creating a subcluster, okay, or I'll be creating a virtual cluster. That is with the help of namespaces. So what this namespaces will do is, namespace is used for providing and workspace. It will provide workspace, okay, for different teams, for, okay, different teams for different environments, okay, to perform activities or running the workloads, running your workloads. That means your pod, replica, everything. So it will give some workspace, something. Every team will be given some space where they will be executing the respective activities. What are the deployments they want to do? Whatever the service they want to create? Okay, what are the workloads they want to run? Everything they'll do in the respective scenes. So they will not disturb some others people workspace. That is where the namespace came into picture. So from a single cluster, you can give a workspace to the respective teams and they can go and work on their respective activities, right? So by default, okay, there are something called a default namespaces. Default namespaces. Okay. So the among this first one, the namespace itself is default. Okay, one of the namespace itself is default where all the user workloads, user workloads like your pods, okay, your replica set, your deployment, your services are running. Second is your cube system. Okay, cube system where you have your cluster objects. Okay, cluster. Okay, so all your cluster related resources or objects will be running here. Okay, so we have already seen when you run this command, it will show you the complete objects or clusters. Okay, and show you the respective, and then you have your kube proxy. Okay, kube proxy, this will have a networking objects. All the networking related objects will be there. Okay, all the networking objects will be there. So you can just run this command called kubectl get_ns to give you all the things. Obviously, the public and this node list doesn't have anything, it's empty. It's empty. Right? These are namespaces, and then how do you access this namespace? Just now I told you, right? So kubectl. Okay, kubectl create. First, you have to create a namespace. Okay, and then kubectl create namespace followed by namespace name. So I'll give a namespace name as QAT. Okay, if you want to access this namespace, kubectl get_ns or namespaces. Get_ns or namespaces, right? Get_ns or namespaces, and then same way you can describe it in case you want to describe it. kubectl describe namespace followed by QI content, and then kubectl delete namespace. Okay. Kubectl get namespace QI get namespaces, describe namespace, and delete the namespace, right? So this will create a namespace. So just it is creating a subcluster or virtual cluster for a team. But how to use this one? Okay, how to use the namespace? So how to use the namespace for creating and accessing the workloads? Okay, how to create a namespace and accessing the workloads. So we'll be using a command called any command hereafter you run kubectl, for example, -f, you're creating one pod, a pod definition.yml. Okay. You have to add the namespace at the end of the thing. That means if QA team want to access their namespace, they want a separate workspace, then definitely they have, right after the command they have to add -n namespace. Right after any command, what are the command, let them run, they let them run any of the command, they have to pass. Okay, if they want to get the pods, or if they want to describe and then if you want, they can delete your pod and then second pod right? So whatever activity you do, you have to pass -n. That means any command you trigger, definitely there should be -n followed by namespace. Okay, followed by namespace. This is how they'll access the cluster. So any resource you create, you have to run this one. Okay, you access, you create, you want to delete, you want to modify, whatever you do it. Okay, everything you have to pass with the help of this one. This is how you can create n number of namespaces. Okay, and that namespaces can be assigned for your respective teams. So that is how you can easily, if you want to test multiple environments within a single cluster, that is possible with the help of this namespaces. Okay, so same deployments you can run multiple namespaces. That will help you to test your complete different test your complete workloads on a different environments. Okay, that is how your namespace is used. Okay, now, you can pass it this one, or if you want, you can also add your namespace directly inside your pod. Okay, inside your pod or deployment. I'll show you the pod. You can also add in the deployment. Okay, so only for the first command, you're just adding your first command, right? Which is YAML file. Okay, if you want to add for a pod definition, just under the name, under the metadata, you can add a namespace. Once you create the namespace, once you create your namespace here, you can just add, or if you want to hard code this namespace, you can hard code this namespace to the respective YAML file. In case you want to hard code, even if you don't add here, no issues. This command will still create that resource, create that respective object inside this namespace. Right? Let's see the execution part, then we'll go for your respective objects. Let's go and create a namespace is created. You can see there's one namespace called QIF. 2 seconds ago it got created. So you can create multiple namespaces, and then kubectl ns or kubectl get namespaces. Then you have a describe command. If you want to describe, you can describe it. If you want to describe, okay. No resource quota, no release name. So nothing is there currently in that. We didn't add anything. And then in case you want to delete it, right? So now what I'll do is, okay, not what I'll do is, first if you see kubectl get pods, no resource in default namespace. That means by default till now, what are the commands you trigger is a default namespace, right? If you run -n QA-team, this will run in the, this will go and search in the QA-team namespace. So both are different spaces, different workspaces for executing, right? Now, for example, if I run kubectl create -f, okay, I'm running your deployment line, right? This is creating a deployment. So where these pods will be shown? These pods will be shown in the default namespace. Okay, these pods will be shown in default namespace. How I am saying it is going to showing default namespace. First of all, I'm not passing any -n. Okay, that means it will take default. Otherwise, just describe it. Even if you describe, it will tell you that where exactly this pod got created, right? So this pod got created in your default namespace. Okay, you can see in the describe command, you will be able to see it in the describe command, right? Now, if I am able to write kubectl get pods, I'm able to see. But if I pass -n q-team, no resource found, right? So I'll run kubectl create -f pod definition -n qa-team. Now this should create inside QA namespace. If I do kubectl get pods, I don't see that nginx pod. Okay, this single pod is not there. But when I pass kubectl QA namespace, I can see my pod. So both are running in different places. That's the reason if you see the command, okay, both the pods are different. Here the deployment pods are running. Here a single pod is running. Okay, both are differently running here. Fine. So if I want, I can create a. If I want, I can create your. Okay, deployment also here. If I want to create a deployment or replica set, that is also possible. For example, if I want to create -f, recreate, okay, deployment -n qa-team. This will create respective things in the respective namespace, right? So go and create a respective namespace. See, 30 pods are getting created here, right? Now, here, okay, here, till now you saw that deployment So till now, what we saw? We saw that your pod is managing your containers, replica set is managing your pods, deployment is managing both replica set and pods. Now, till now, what did you do? You are running the entire deployments in the default namespace. You are running entire deployments in the default namespace. But now you can create n number of namespaces. If you want to create n number of namespaces, you can create n number of namespaces. So one namespace which you create is QA namespace. So what are the resources are there? You can able to create in multiple namespaces. How many namespaces you want to create? That many namespaces you create and put your different level of workloads which you can test it for different applications or different environments. Fine. So now in this scenario, for example, now I created QA for namespace. Okay. If we have seen that if I create a deployment, replicas and pods are created. But when I delete a deployment, what will happen? Deployment will get deleted, replica set will get deleted, as well as the number of pods what you have, it will get deleted. Okay, if I delete a deployment. Same way, when you delete a workspace, automatically everything will be deleted because this QA-namespace of workspace, which is a subcluster. If you're deleting the subcluster, obviously all the components in the cluster will be deleted. Okay, so that is very easy way of maintenance. So while creating, you'll create it. While deleting, while destroying it is easy. You don't need to go and search one thing. Where is my replica set? Where is my deployment? Where is my pods? And you'll delete it manually. No, just delete the namespace. Everything will be deleted for you. Everything will be deleted. Whatever it is there in the namespace, everything will be deleted. So easy way of tracking. You can easily track your resources under one namespace. Okay, for which environment. So what is what kind of activity is happening in that namespace? Everything you can easily track it. Okay, and easily you can destroy it. Easily you can maintain it. That is where your that is where your respective namespace will help. Okay, if you see here, now we created under this. You can also put like this cubes. It will get all. So we created this respective pods. We created the respective deployment. Now, if you delete this namespace itself, kubectl delete ns QA-thing. This is a namespace name. I'm deleting. So that means you're deleting the entire namespace. That means entire components under the namespace, entire workloads under the namespace is getting deleted. Okay. Now everything will go from here. Everything will go from you. You don't want to delete it manually one by one. You can check here. Okay. No resources from namespace. But first of all, there's no namespace only. There's no namespace for QA team. You deleted everything under QA team. That is how it will work. That is how your namespace works. So benefit is there where you can easily track it. Okay, you can easily manage your resources and then you can easily destroy them in a single shot. That is where your namespace will help you. Right? So let's see your volumes. Now, what are these volumes? Where it will help you. Okay. So same thing we saw the volume inside a Docker as well. Same thing here also you'll be using. Okay. Same thing here also you'll be using it. So volumes are storage location for storing the data. It says storing or fetching the data. Okay. From the to or from the pod and the worker node. So here these worker nodes are basically managed worker nodes. We are not managing it because we are using AKS. You are using purely AKS. So AKS, what it does, it manages its worker nodes, it manages cluster. Okay. But when you install your Kubernetes with the help of any of the self-managed Kubernetes cluster, then you will able to see a worker node. Otherwise, here it's difficult to go and check your respective node pool. So it is everything is node pools, right? You cannot log into node pools. It will not allow you to get any information from the node pools, right? So let's see here. This is the operating system Kubernetes cluster. Okay, nodes are given here. Okay, you can scale node pool if you want to increase the node pool. Okay, you want to update the image, you want to update the Kubernetes, you can do it from here. All that information will be here. Okay, and you have this nodes. So we created some 2 nodes minimum, and we added to the auto scaling. So as soon as the load increases, number of nodes will come, right? So in this nodes, you'll find your pods. So what are the pods are running? We'll show you the respective pods. Okay. So if you see here, Nginx deployment, which we were running, right? So that respective deployment is running. So deployment which is there in this deployment that is running here. Okay, you have this respective pods it is showing you here. Okay, respective pods it is showing you here. All that information is here, right? So, but it will not allow you to. It will not allow you. Okay, it will not allow you to go inside this respective node pools. Okay, because it is managed node pools. If you create a customized node pools, then you can log in. You can go and do some configuration in that. So all that things you can perform. But here, this is purely managed by your AKS. Okay. So whatever you have to do, you have to do it from your kubectl level. Okay. Whatever you have to do, you can do it from your kubectl level. Right. Only thing is, benefit is it will show you from the graphical user. Okay. You don't need to connect every time to command line. If you want to verify something, you can go and check it from here. You can go and check it from here. You can see that 2 nodes are there. You have a count of 2 nodes. It will take you to the same nodes. And if you want to scale up, you can easily scale up. You have this option to scale up. You can maximum, you can scale up the capacity if you want to scale up the respective capacity, right? That is possible. Let's go and try to see how we can add a volume. Okay. So we'll take a pod definition. You can add it to your deployment. Okay. You can add it to the deployment, similar way. How you adding to the pod? Just in the pod section, you will mention in the deployment. Now here, same pod. Now how do you add this one? We will not disturb this YAML file. We will take the wall. Okay. And here also I'll say this wall and remove this namespace. We don't have it. Now, this is your respective pod definition, simple pod definition. So where do you create the container? Okay, to and from the pod and replica. So pod will be created inside the container. Sorry, your volume will be created inside a container, right? So under the container, you'll be writing something called volume mounts. Okay, space. Give a name to this volume. I'll give a host volume. You can give any name, and then you have to give a mount path. Okay, mount path colon, give a path. I'll give this as container slash DevOps. Right, and same way you have to create one volume. Okay, under your worker node. Okay, that means what are the worker nodes are there, or the node pool is there. Instead of node pool, will be creating it. Right. So here we have name colon host underscore wall host path. So I'll say this is my worker node slash data slash containers. Right? This is how you write it. So here, this is your pod volume. Okay, and this is the mapping. So how this container volume talks to his pod, talk to the worker node volume. This is the mapping. This naming convention you're seeing, right? This name and this name should be same. If that naming convention is same, then there is a mapping between both of them. Okay, both will get synced. Okay, mapping between your pod and your worker node. Okay, that is a mapping between pod and worker node which you need to maintain it. Okay, both the places it should be same. And this is your worker node volume. Okay. And the execution is same, no change in execution. kubectl create -f pod definition. Okay, and then you have kubectl get pods. And if you want to describe, you can describe. Describe will give you both the details about this volume which are created. It will give you in detail about this volume. And now, if you want to see the volume of your container or your pod, go inside the pod definition and give your container name and then do a bash. Okay. Once you go inside your respective container, okay, this is a container 100. So this path, okay, this path will be created, okay, at the time of pod creation. At the time of pod creation, this path will be created. You don't need to go and verify this one. Okay, this path will be created. Same way, your worker node also path will get created, but that will be inside your managed node. It will be inside your managed node, right? And whatever you write here, that data will reflect it. Whatever you write here, the data will reflect it, right? Now, let's go and see this one. Let's go and create this one, and let's see that. And before that, kubectl get all. Okay. kubectl deployment and remove this one. Okay, just removing the comments. Okay, so let's go and create this one. kubectl create -f. Okay, kubectl get pods. You have your pods running, and now describe it. You'll be able to see both the volumes. Describe your pod, and you can read your pod related information here. If you see volumes, this is the host path. Okay, this is the host path which is created within the respective host worker node. Okay, and whereas under the container, if you go on the container, under container they'll create your okay mounts, which is the app container Devops. This is the host volume, which is the app container Devops, right? So it is created here. Okay, so both the locations. If you want to go inside container, you can go inside kubectl exec -it. What your container name is, your pod name is, you can see your app. This path will be get created. So your path got created here. Okay, and what are the data you want to put, you can put it here. Okay, this will store the respective data, or inside your Docker file. When you're writing a Docker file and you say that I want to capture some data, I want to get some data out, etc. things, you can do it from there. Okay, etc. things you can do it from there. And same information you can see, you should be able to see here. Let's see this. is reflecting both the nodes. And here under the pods, where is that pod got created? Here it is last. You go inside the pod, you'll be able to see the details of that pod. This is the container. All the resource utilization, everything it will tell you. What is the disk usage, how much is CPU, everything it will give you, all the details. And then go inside this respective container. Okay, you'll be able to see the host one. Okay, host volume, which is here. Okay, host volume, what are the environment variables you create, all the details it will show you. Okay, all the respective details it will. Okay, this is the details which you. But data will not be visible. That will be encrypted. The data will be seen only from the kubectl. If you want to go and check the kubectl data, you can go and check the respective kubectl data. Okay, that will be available if you want to see the respective details here. Okay. So you can create a respective volume. You can send the data. Okay, in case you want to send the data, you can send the data, or you can capture some data within the volume. Okay, so all the logs and everything you can see it again. You can see the same logs from your monitoring. So they are enabling your Grafana. If you see here, if you just saw this here, they are also enabling your Grafana over there. So that is one of the monitoring tool, okay, which is inbuilt within your Azure. See your Grafana workspaces. That is where it is giving you. It will give you all the works, but this has to be enabled when you're creating that respective one. Okay, link your Grafana instance. So basically, when you're creating this Kubernetes cluster, that time it is asking to enable Grafana, but that will charge you based on the use case what you want. Right? This is where your volumes will go. So just to store some data or just to get some logs, that is where we use it. Okay, that is where we make it. But problem with this managed cluster is this is completely managed. It will not expose most of the data for you. Again, you have to attach additional things and everything, additional monitoring tools and everything to get the logs and everything. You have to attach it, only then it is possible. So when you go with KubeADM or you have POPs, okay, so there are different ways of installing this Kubernetes. Okay, so that time you have a control over master and worker node. Both are in your control. You can get the data, you can push the data, everything. But that is little bit complex to manage. Okay, there will be a lot of uh, things which you need to manage manually. But here it is automated fashion. Just within few minutes, your cluster will be created. Everything will be taken care of it. Okay. See, auto scaling is also automatically done here. Okay. In case you go with your KubeADM kind of a manual setup. Okay, if you go with this kind of a setup which you have seen here in the architecture, in that situation you have to manage this both the nodes. Okay, add it under respective any kind of auto scaling mechanism in your Azure, and then you have to use it. So your effort will be here. You have to manage the master node, and then you have to manage. But here, master node is completely and the worker node is completely managed by it. Okay, you're not going to. Okay, you're not going to configure, you don't want to troubleshoot everything, it will troubleshoot automatically. Okay, it will take care of everything. You don't need to worry about it. Everything it will take care of it. It will automatically scale up the nodes, it will automatically scale down the nodes. Okay, you just need to give some parameters, it will take care of itself. That is where your managed Kubernetes cluster which are using is AKS. Okay, same way we can see your environment variables. So what is the use case of this environment variables? Okay, why do we require this environment variables? So basically what will happen is whenever you're writing this, okay, whenever you're writing, okay, whenever we write a Docker image, so this Docker image is written by us, but inside this Docker image there is an application. So this application inside your Docker image, okay, requires your env variables, okay, to make connections. That means, for example, your application is trying to connect your database. or your application is trying to connect some any of the cache mechanism, or application is trying to connect any of your other clusters, okay, or any other endpoint is trying to connect. So in that situation, you have to pass some parameters. That parameters are passed with the help of your okay. To okay, we require environment variables to make connection. That means, for example, developer have written inside his code saying that my application will go and connect to DB. Now, what are DB parameters? DB hostname, DB username, DB password, or any other parameter related to DB. So that parameters we can pass it with the help of environment. So what developer will do? He will mention all the respective environment variables name which you're creating here inside the code, and that code will respectively take these values from your respective pod environment variables, and then it will go and try to connect when the application is up and running. When this Docker container is created, it will try to see this environment variables and it will try to use that. That is where this environment variables will enter. Okay. So developer will tell you, okay, how to add this environment variables. You just need to mention it here, how to pass these values and everything. He'll give you with proper information. Give you a proper information. Okay. What environment variables he has used, what is the naming convention, okay, what value it should have. All the information will be given by a developer. Developer will share that environment variable information and will be using inside of code. Okay? So this variable is a temporary storage location storing of value. So just add env and add a name, and then you say db user is the value of that. What is the value of that? This is a db. For example, it's a db Facebook user. Okay, db Facebook password, some random ID. Some random ID, right? No. And then we have a name. db server dot. So this is how you give your username password, but this password should not be mentioned here like this. For this, there is a mechanism called secrets. Okay, I'll tell you. I just gave it temporarily now. So this is how you add your environment variables. And this environment variables, what will happen, right? Okay. So here, this developer, what will use? Okay, he will use inside his code and he will give you some extra commands here. Okay, when you want to proper properties, he'll give you -d parameters. There are something called -d parameters. That -d parameters you'll be passing it here. You have passed this -d parameters in the Maven, right? Same way here also will be passing this -d parameters after at the end of this image, and the developer will give you how to make use of this. Developer will give you how to make use of this parameters. Okay, he'll be adding in with the Java options and etc. things. He will be adding there. He'll be giving you the command. You just need to add it, and then the respective parameters values will be taken from here within your application. And then execution is similar. The way you did for this one, the same way you'll be doing it here. And you can verify the values in case you want to verify. So once you go inside, you can verify environment variables. So just type env, it will display all the values. Env will display all the values. If you say that no, I want to see my specific value, use a dollar symbol, equal space dollar db user. What are the password it is? Okay, db password. Okay, db. So this will give you your respective values, whether the environment variables are working or not. How to verify? You can verify from here. You can verify it from here whether these values are properly captured or not. Okay. And then the respective command will be shared by developer. Developer will write this respective -d properties command for you based on the parameters used inside a code, and then that respective parameters will be used within your Docker image. Okay, and that will connect to the respective application. That is how your environment variables are used. Okay. Now, as this password is exposed here, how can I encrypt this password? So that password will be encrypted or stored inside a secrets, which will not be exposed to the outside world, which will not be exposed to the outside world. Okay, will not be exposed to the outside world. Okay. Let's execute this one first, and then we'll go to. So same, all these details, environment, your volumes, your secrets, everything can be added in the deployment as well. Same under how did you add in the pod, same thing you can add under the deployments. Okay, that will increase your complexity and will increase the size of your respective YAML file. Right? And you can see here it is created. Now you describe it. While you describe also, it will give you the details. Okay, while you describe also, it will give you the details. You see your environment variables. Okay, I believe this should also be seen under your pods. To the environment variables is listed here, right? But this password should not be visible here. For that, we'll make use of your secrets. We'll make use of your secrets. Okay, okay, that will make use of your secrets. That secret will hide your respective password. Right? You can also see this inside your exec. Just say env value or just see equal. In the env itself, you can see db user, db host, and db password will be here somewhere. Right? DB password is there. Right? So echo dollar DB host, your DB user, and your DB password. So all the things will be displayed here because it will interpret within your container, so it will display everything. Okay? It will display everything. This is how you add your environment variables. Okay, so this will be used within the code by developer to make some connections. That is where we make use of the environment, so that you can pass it dynamically at the runtime. You can pass this environment variables. Okay, as soon as the container is populated or created, this environment will go and make a connection with that. Right, and then you have secrets. Okay, so secrets I'll take in the next steps because secrets will take time. First, you have to create a secret YAML. Then you have to include that inside your. You have to make a base 64 encryption. Okay, you have to do the encryption here, and then you have to make use of inside a secret of pod, right? To take some time, and then we have a networking. So we got networking. Okay, and then I'll give you a final deployment YAML file, which will include everything here. And also I'll give you your Tomcat deployment YAML, Tomcat deployment and service YAML file. Okay, you can take these two and start executing. Okay. Okay. So just to inform you, tomorrow also we'll connect. Okay, because like we didn't connect for a few days in between because of that holidays and that festival season and everything. So we'll connect tomorrow as well, and then we'll connect Tuesday. Okay. So Monday hour you have Sunday, so you guys will not connect on Monday. So tomorrow, same time, 6 o'clock. I'll connect at 6 o'clock and we'll have class. So we'll complete this Kubernetes part. Okay. And if time persists, I'll start a JFrog because JFrog is not completed. So once you complete JFrog, then we can go to Jenkins. We'll start a Jenkins activity. I'll show you first in Jenkins, then I'll show you in your Azure pipelines. We'll go to Azure pipelines. After you learn Jenkins, you'll get some clarity about how to write a pipeline and everything. Then we'll go and learn about your Azure pipelines. Same thing, I'll show you the Azure pipelines, how it works. Okay. So we'll see your Kubernetes tomorrow. We'll close this part and then I'll take you to the JFrog. Okay, JFrog is a small tool, will not take much time. We'll close that and then we'll from Tuesday we can start your Jenkins part. We can start a Jenkins part. Jenkins, once we cover Jenkins, we can start your automation part. Okay, you'll be able to learn the automation part. And then we'll see what is pending. We'll see the pending part and we'll so because Jenkins is required to connect all these tools. Okay, Jenkins is required because Jenkins will take time to learn. Okay. At least it will take like 5 classes minimum it will take to learn the Jenkins. Right? Because there's like some topics are there which will help you to do the automation. So let's pause it here. Let's connect tomorrow and let's close this few minutes one and then we'll go for your respective JFrog. Okay. I'll complete a JFrog tomorrow and then we'll go for the Jenkins. Okay, then. Any questions, guys? Any questions, any queries, any doubts? Okay, then. Let's pause it here. Okay. And make sure you stop the cluster. The charges will be very high. Okay, so make sure you stop the cluster because there's the 2 nodes running. There is some IP address are getting exposed. So make sure you stop it because otherwise the charges will be high. Thank you, guys. Bye-bye.
Thank you.